Hi, my name is dr. Ahmath. In this lecture, we're going to start talking about the exponential numbers. And today we're going to introduce the exponential numbers, its notation, and we're going to talk about its properties. And also we're going to see a couple of examples how to use these properties in our calculations. So first of all, we're going to introduce an exponential number. So let's assume that you would like to multiply some natural number, let's say 2, to itself, like 5 times. So 1, 2, 3, 4, 5 times. So we've just multiplied the 2 to itself 5 times. The thing is, like, writing down the multiplication of a number to itself lots of times takes a long time and lots of space. So one of the ways to save the time and the space would be to just write this down in a more compact form. So let's say like a 2 in the power of 5. So the multiplication of a number to itself 5 times can be written in this number in the power of 5. So in general, we're going to write down a in the power of n as the multiplication of the a to itself n times. So if you just multiply the a to itself n times, you can just write this as a in the power of n. Here, we are going to introduce some notation. N is going to be the exponential of this number, or the power exponential, or the power of the number, and a is going to be called as a base. Okay. For example, if I say, hey, could you please tell me what is going to be 3 in the power of 3? It is going to be the multiplication of the 3 to itself 3 times. So the same works for the when the base is going to be a negative number as well. So for example, if you would like to just get minus 3 in the power of 3, this is going to be minus 3 times minus 3 times minus 3. So which is going to be equal to the minus 27, right? Okay, so the question is, so if we are defining this exponential numbers with the n, with the power n, can this n be negative? So this is one of the questions which we would like to address in the beginning of the lecture, and hopefully until the end, we're going to try to answer to this question. Can n assign a negative number? Or can v assign to the n a negative number? Okay, so this is going to be our question of the lecture. So let's start with the properties, or we would like to try to get some of the properties of the exponential numbers. And the first property, properties, which we would like to start, is going to be like this. So let's say I would like to multiply the first property. So I would like to multiply 2 to itself 3 times. So basically 2 times 2 times 2. At the same time, I'm going to multiply 2 to itself 4 times separately. It's going to be 2 times 2 times 2 times 2. So we know that as an exponential, we can write down this term as a 2 to the power of 3. And we know that as an exponential, I can write this term as a 2 to the power of 4. But at the same time, if I decide to multiply all of these numbers together, it's going to be the multiplication of the 2 7 times, right? So 1, 2, 3, 4, 5, 6, 7. 7 times, which actually can be written as 2 in the power of 7, right? So this is going to be 2 in the power of 7. So what's a law is that, like, if you multiply 2 in the power of 3 to the 2 in the power of 4, it's going to be equal to the 2 in the power of 7, which basically defines our first law, which basically tells us that, hey, a in the power of n times a in the power of n is equal to the a in the power of n plus n, where please note that this base and this base and this base are the same. So we can work only when the base are the same. So the second property is going to be the similar one, but when we are going to divide them. So let's do the second property. So property number 2. So what I'm going to do is I'm going to take this 2 times to itself like 4 times, then divide this 2 times to itself 3 times. So we know that the 3 2's on the numerator are going to be just cancelled with the 3 2 on the denominator, and the answer is going to be equal to the simply 2. So if I would write down everything in terms of the exponential notation, we would get the following terms, like 2 in the power of 4 divided to the 2 to the power of 3 is equal to the 2 in the power of 1, which leads to our next load, or to our next property. It's going to be a in the power of n divided to the a in the power of n is going to be equal to the a in the power of n minus m. Okay, good. So the property number 3, let's say, is going to be about the powering up the exponential number already. So let's say you've got an exponential number 2 in the power of 2, okay? And then what you would like to do is you would like to power this 2 in the power of 2 to the 3 as well. And I would like to know how to express this in terms of the powers of the 2. Okay, so we know that any exponential number here, any exponential number in the power of 3 can be written like this: 2 to the power of 2 times 2 to the power of 2 times 2 to the power of 2, right? At the same time, this 2 to the power of 2 is the multiplication of the 2 to itself, right? 2 to the 2, 2 to the 2. Right? So what does it mean? It means that you need to multiply this 2 in the power of 2 to itself 3 times. Then again, every 2 here should be multiplied to itself 2 times. So which leads that I need to multiply the 2 to itself 6 times. So it's going to be 2 in the power of 6. So let me explain you this with other numbers, because maybe 2 in the power of 2 is a little bit confusing. So let's start this with the 5 in the power of 2. Okay, in the power of 4. What does it mean conceptually? It means that I need to multiply 5 in the power of 2 to itself 4 times because of this 4, right? But at the same time, 5 in the power of 2 means that I need to multiply 5 to itself 2 times. For all of these 4 cases, I'm going to have, for every of these 4 cases, we are going to have 2 more cases of the 5s, right? So which leads us to another formula, which is basically going to be 5 in the power of 2 times 4. Okay, so this is called something like a general counting rule. So if you can have like n events where each of this n events can happen in n other different ways, then total number of the cases is going to be the multiplication of the n to the n. So here it's going to be in a similar way. So basically, a in the power of n in the power of n is going to be a in the power of n to the n. And now we are going to use this law, the property number 3, in order to derive property number 4, which is going to be really important, and it reveals a couple of like fundamental questions or fundamental things, like a property number 4. So let's say what I would like to do is I would like to find the so we already know what is the minus 3 in the power of 4, for example, right? What I have to do is I need to multiply minus 3 to itself 4 times, which is conceptually understandable, right? So it's going to be 9 times 9, right? So this is 9 to the 9, which is going to be equal to 81, okay? At the same time, what if I would like to find like 4 in the power of minus 3? What is this? So conceptually, it is not so clear what does it mean, right? So that is why I'm going to use this rule. So in this rule, it tells me that I can multiply the powers of the powers, right? But at the same time, I can split this. So what does it mean? So I'm going to write down 4 in the power of minus 3 as 4 in the power of minus 1 in the power of 3. So this is really important. because I know what is the 4 in the power of minus 1, right? So any number in the power of minus 1 is going to be 1 over a, and this number is actually called as a reciprocal of the a. So for example, if I say, hey, what's a reciprocal of the 2? So 1 over 2 is going to be a reciprocal of the 2. Okay, so now we know that the 4 in the power of minus 1 is equal to the 1 over 4, right? So this number in the power of 3 is going to be simply 1 over 4 times 1 over 4 times 1 over 4, and we can do our calculations, right? So the 4 in the power of 3 is 64, so this is going to be 1 divided to the 64. So which leads us to another law number 4, or property number 4, which tells us that, hey, a in the power of minus n can be written as 1 over a in the power of n. Okay, so this is also a really important rule, and we can even derive this for the general case. For example, a in the power of minus n can be written as a in the power of minus 1 in the power of n, which is going to be 1 in the power of 1 over a in the power of n. Then this is going to be like a 1 in the power of n divided to the a in the power of n. So 1 in any power is simply going to be equal to the 1 divided to the a in the power of n. So this basically 4 rules or 4 laws are going to define lots of other things. So all the operations of with the exponentials can be written using these 4 laws. So let's do a couple of exercises in order to and use those laws in order to simplify some of the exponential terms. Let's do an exercises. For example, let's say what I would like to do is I would like to simplify the following term: u in the power of minus 2 times v in the power of 3 in the power of minus 4. Okay, and let's see what we can do this. So minus 4, it means that I can just like, okay, so if I have the multiplication here, I can apply the exponential to each of them. If it is sum, I can do this. We cannot do this if it would be the sum here. So, but since it is the multiplication, we can do this. It's going to be u in the power of minus 2 in the power of minus 4 times v in the power of 3 in the power of minus 4. Okay. So at the same time, we know that we can just multiply the powers of the powers, right? It's going to be u in the power of minus 2 times minus 4 times v in the power of 3 times minus 4. So this is going to be u in the power of 8 times v in the power of minus 12. But at the same time, we can write down this as the u in the power of 8 divided to the v in the power of 12, according to our last law. So let's do another exercise. So this is the first exercise. And the second exercise, let's say, is going to be the simplification of the following term. So 2r cubed divided to the s in the power of 2 times s divided to the r in the power of 3 in the power of 3. So I'm going to open up the brackets separately, then I'm going to multiply them. So this is going to be 2 in the power of r cubed in the power of 2 divided to the s squared multiplied to the s cubed divided to the r cubed in the power of 3. So let's first of all apply the second rule, for example, third rule, where we are going to multiply the powers. So first of all, so 2 in the power of 2, so 2 in the power of 2 times r in the power of 3 in the power of 2, it's going to be simply 6. Divided to the s squared times s cubed divided to the r in the power of 3 to the power of 3, which is equal to the r in the power of 9. So now what I would like to do is I would like to regroup all the terms, like r's separately, s's separately, and the constant t separately. So 2 in the power of 2, it's going to be 4 times r in the power of 6 divided to the r in the power of 9 times s in the power of 3 divided to the s in the power of 2. So now we're going to apply the second rule in order to simplify the terms. It's going to be 4 r in the power of 6 minus 9, because it's a division, times s in the power of 3 minus 2. So this is going to be 4 r in the power of minus 3 times s. And at the same time, r in the power of minus 3 can be written as a 1 over r in the power of 3. it's going to be 4s divided to the r in the power of 3. So these two are the examples of the usage of the properties of the exponentials. So in our next lectures, we're going to talk about how to apply. So what are the applications of the exponentials in our real life?